Step 1, get yourself some medicine. Step 2, get ready for spontaneous or non-spontaneous half reactions. This is a part of the redox reaction family. Step 3, get another drink. Redox reactions, reactivity involved in it. So there's some things you need to know beforehand, like ions. Losing electrons means you have, you have a positive charge. That's a cation ion. Gaining electrons means that you're an anion. If you don't know it, go review it. Reduction. Gain electron equals reduction reaction. GER. Leo goes GER, right? Here's the GER. Oxidation, losing electrons. If you don't know what I mean by these, you gotta go find out what those are. Maybe you're gonna learn here, I have no idea. But right now is not the time. We're gonna hit it hard. I'm gonna go through what you need to know how to do, and then I'm gonna go over an example. So you can cut forward to the example if you want. It's all good. Basics. Number 1, okay? We start with a balanced equation. So here's my balanced equation that I have, something that I give my example here. Silver usually comes tarnished. It's usually silver sulfate, and we mix it with some solid zinc. And guess what? This is a single replacement reaction. Then it becomes zinc sulfate and silver, purest of the pure. Now, of course, we balance that thing. Got to balance that thing, all right? So step 1 is done. Step 2. Now, sometimes you're not even given this reaction. Sometimes you just use, the half reactions. I'll show you what to do with there. Step 2 is we really need to identify each atom as an element or an ion on both sides of the equation. So let me show you what that looks like. First of all, we have this silver. It's in a compound already, which means this is an ion. Okay? Now, that's a reactant side ion. Now it goes over to the product side, and we have pure silver. That's an element. Okay? Let's go to this zinc here. Here is an element. That's easy, and it produces an ion because it's in a compound. It's pretty important. You should remember that one. And of course, we have this weird thing. Sulfate is over here as an ion, and as a product, it's still an ion. Nothing has changed. It's ion and ion, which means we call it a spectator ion. Now they watch the football game, right? They watch the basketball game. They watch the ping pong game. They're a spectator. There's nothing going on in there. This is a really important step. Identify where the reactants, where these elements begin as an ion or element. So atom, language. Oof. So step 3 is you're going to be writing a reduction and oxidation half reactions. So I'm going to start with silver. First of all, we can see that silver starts as an ion. So I wrote it down. Here's the ion. And then I have to add 2 electrons, because if a silver ion gains 1 electron, then it becomes 1 silver. But in my equation, in my reaction here, I have 2. So 2 silver ions plus 2 electrons, they gain 2 electrons, which means you have made 2 solid pieces of chunks of silver. They have gained electrons, that's GER, right? Gaining electrons means reduction. Okay, so there's my half reaction for silver. And again, I have to note, you have to remember it starts as an ion, finishes as an element. So in this half reaction, it starts as an ion, gains electrons. This is a half reaction because this is part of the giant whole equation. So let's move me over here, right? Can't even see. It made me puke. All right, back to this. So now we have the other half reaction of zinc. Zinc starts as an element in the reactant side, and if zinc blows up and loses electrons, then it becomes 1 zinc ion, and that's zinc, 2+. But again, it has to lose 2 electrons to do so. It's all balanced, it's all great. It loses electrons, that means LEO, that's oxidation. Now I want to point out a little geographical hint for you. If in your half reaction, you're gaining electrons in the, or sorry, let me rephrase that. If the plus 2 electrons or the plus electron is in the reactant side, you are gaining electrons. However, if the ion and the plus electrons is in the product side, that means that you are losing electrons, therefore oxidation. Now, we want to find out if this is a spontaneous reaction or not. So what we need is this little thing here called the reduction half reaction table. This is something that I give to my students in their data booklet, and it's something maybe you have. I want to point out that you can see, here's my 2 half reactions that I wrote before. This half reaction for silver, the silver ion, it's written already on the table. So you didn't really need to come up with that on your own. It's written right here. It's a present. Now, you can see that because I am gaining electrons in the reactant side, this reaction I'm reading from left to right. And if I'm reading it from left to right, that means this is the reactants and this is the products and this is GER, that is reduction. And here is my other, right? I found my other half reactions. Again, don't worry about doing this on your own. You should be able to, but don't worry about it. Look, it's right here. But here's my other reaction. But notice I have to start on this other side. Now, this is the tricksy part that I find my students struggle with. I really do. That's why I'm going to take another drink. Anyways, zinc starts as an element. So this is the element side over here. And this zinc right here, this is my half reaction. But because I have to read it from right to left, I'm going to have to write this from right to left. But that's why the half reaction starts with zinc, silver, an element, and it produces the ion. It means you start as an element, and then this metal blows up and it loses electrons. That's why this is the lose electron side. If this is the reactant side in your general equation, and you have to read from right to left, it's going to be oxidized. Now, there's a rule, okay? You have to be able to turn this in your head, okay? Because nobody's going to help you. So that's why I drew this little arrow here, right? So now here's my half reaction. I just wrote it like that to help me out. So now spontaneous or reactive. You'll notice that these arrows here, okay? Here's one in purple and here's one in orange. And we have this side is my ion side. This goes in increasing reactivity of ions, which means gold 3, that's the most reactive ion on this table. Lithium, not so bad. Now, over here, these are my elements. Now, that means the reactivity of the elements increases as you go down the table. And lithium, the lithium ion, is the most reactive element. But the most reactive element has the least reactive ion. Now, we use this to generate the idea of what a spontaneous reaction is. But here's the general rule for that. If the reduction half reaction is higher on the table than the oxidation half reaction, then you have what we call a spontaneous reaction. Spontaneous simply means that this whole reaction will occur without any extra energy. That's it. So you don't even have to worry about the definition. You just need to say, hey, do you see this right here? This is my oxidation reaction because I'm starting from the right to left, and this is my product side now. And this is my reduction reaction. Do you see how it's over top of my oxidation? So if reduction is higher on this table than the oxidation table, then it's spontaneous, and that's all you need. So that was the step-by-step. Now I'm going to go over an example. You can pause and rewatch this, or just let's continue. Good idea. Lightning speed. All right, here we have the table, and of course we need a reaction. So it looks like gold is reacting with hydrochloric acid to produce hydrogen gas and gold 3 chloride. Ooh. Okay, so here's my balanced equation that I did in my head, and now we have to look at the elements. So let's start on the left. Gold starts as an element, ends as an ion. Ooh, that means it has to lose reactions, so that's going to be, or lose the electrons, so that means it's going to be oxidized. Hydrogen starts as an ion, so it has to gain electrons to become an element on the other side, so that's going to be reduced. Take a look at chlorine. Those are That's right, spectator ions. All right, so we write the half reactions. Hey, look, I have this table. I'm just going to write what I see down here. You can, but remember it needs to be balanced. So I'm going to balance it for you. So here is my gold, and you'll see because I'm starting over here on this side, I need to read from right to left. And that means lose electrons, oxidized. And we found the hydrogen half equation or half reaction over here. It looks like it's already balanced because hydrogen gas is a diatom. It always has two. But we are reading from left to right, which means reduction. So let's copy down these quick equations. Let's start with gold. Here's my half reaction that I wrote down, but I have to balance this. And I can see in the equation that I have two golds here, so I have two golds to begin with. But it produces two gold ions. And so how many electrons do I need to balance that out? Well, in the half reaction, I need 3 to balance out 1 ion, but I've got 2. So 2 times the number of positive charges, well, I need 6 negative charges to balance it out. What we have over here is this is the reduction. And so here we have this, 2 hydrogens and 2, this is the reaction, the half reaction that I have. Remember, I'm reading it from left to right. And so what we have is, balance it the same way. I made a mistake. Guys, look at this. G-O? Why didn't you tell me? Always tell me when I make a mistake. And if I can make a mistake in my notation, so can you. Be careful. Scratch that out. Judas Priest. I'll scratch it out later. I want to bring up something, though, first. See how we lose electrons over here? We gain electrons over there, right? So these have to balance out. Remember that balancing this means if we lose electrons, like gold lost these electrons, and then it gave them to hydrogen so that it could become all of these hydrogen ions. GER. There we go. Now let's look at the table. Here's my reduction, right? Here's my reduction deal. Here's my reduction half reaction. It happens to be below my oxidizing one. See that? The reduction is lower than. That's not good. If we want it to be spontaneous, this sucker, the reduction half reaction, has to be higher than it. Because it's geographically located below, we have ourselves a non-spontaneous reaction. Okay? Look at this. You can't even see it. What? Guys, I made another mistake. Look at this. 12 hydrogens. How many should we have? We should have 6. So let's scratch that off and put a 3 there because now that is a balanced thing. So this is lots to keep in mind. What you need is practice, medicine, courage, and encouragement. You can do it. So why don't you go ahead and rock the spontaneously, please. You see what I did there? I made a joke. It's not funny.